Hello. In this demo, I'd like to talk about how we can implement a TCP versus an UDP concurrent server application. And I chose to implement a simple talk application which will broadcast a message sent by a client to all the connected clients. I have here almost identical implementations with the only difference that one is using TCP and the other UDP. As you may see here, I have packed in one project both the client and the server. So if we go step by step, let me dive into the details of the implementations. I have an utility class in both cases, which is serializing and deserializing messages. Let's just start by talking how we can implement serialization with TCP. Because of the fact that TCP is actually relying on a stream of data and it's acknowledging each package and it is therefore guaranteeing that the message delivered was received. So it is actually also reordering the packages so that they will be consumed in the order that they were sent. Because of all that, with TCP we can implement the serialization as the following. So I have here a receive message, a receive method. Sorry. You know that with TCP we work with a socket, and the socket has an input stream and an output stream. So we can implement the streaming with TCP in two ways. Either with a landmark, so we scan the input up to finding a landmark, or with writing first in the header what is the size of the message. In my case, I think it is better to start with the send method. If I'd like to serialize an object of a generic type T, I will use the Java binary serializer, which requires the object to be serializable. So my generic type should be of type serializable. Now, if I like to send this to a socket, what I need to do first? I will serialize the object in memory. So I create a byte array output stream. Next step would be to open an object output stream on top of my memory stream, so that we can use the write object method of this object output stream to serialize my given target, my given object. Then I close the stream so that I can take the byte array that was produced while serializing the object. Now, first thing that I'll do would be take the output stream of the socket and then write first the size of the buffer. And after that, I just write the content of the buffer, starting with the 0 index up to the size of the buffer. Now, because the streaming is using a buffer, I need to flush that in order for all the data to be sent at this point to the remote partner. Now, given the way I implemented the send method, in order to read it and receive a message from a socket, I will do the following. I need to read first the header telling me what is the size of the message, how many bytes do I need to expect to be received. Then I will start with a counter. Initially I received no bytes, and while my counter is less than the size I need to receive, then I take the input stream of the socket and then ask the stream to read in my buffer, starting with the last index and up to the length of the buffer, which should be the size that I need to take. Then I create an input byte array input stream on top of my byte buffer, and on that I create an object input stream just to be able to read an object. And I will cast this to the expected type of the result, which is erased from my generic class. Therefore, I would have to make sure that the actual type I'm asking to receive would be with respect to what I put in the stream. So with TCP, implementing a transport layer like serializer and deserializer is easy as pie because of the way TCP works, which has an attached input and output stream on top of my channel. So I have the streaming done already by the channel. Now, with UDP, things are a bit more complex. And let me just go to the transport implementation of UDP. Because of the fact that UDP doesn't have a connection in the way that we are not doing a handshake and starting a session and then segmenting a payload and attaching some sequence number for each package. Because of all of that lack of implementation with UDP, we need to do the deserializer and serializer totally different. First of all, I will not use a socket but a datagram socket to manipulate an UDP connection, an UDP channel. So when I send an object, let's assume that I have to serialize an object which is serializable. I will have to take care of producing the serialized form of the object, so I create an in-memory byte array output stream, the way I do with TCP as well. And then I create an object output stream on top of this just to be able to write the object. Now I close the stream and then take the byte array that was produced by the serializer. I then need to create a datagram packet over this buffer. But the idea is that because I don't have a session between the partners which are communicating through UDP, each time I send something to a remote endpoint, I need to specify what is the endpoint, what is the internet socket address to which I like to send this. The internet socket address is just an endpoint which is binding a port number to an IP address. So, having configured this routing information for the destination of my packet, I then use the connection datagram socket to just send this to the remote endpoint. Now, when I deserialize, and please note that with UDP, I don't have to specify what is the size of my buffer, because with UDP, you either receive the whole buffer or we don't receive it at all. So this is something different from TCP, where I need to handle a stream of data that it's supposed to be infinite. In this case, with UDP, I just write my content buffer, and then when I receive, first of all, I need to make sure I create a buffer which is enough for receiving all the data. So this is a limitation. I don't know, I don't have a window specifying how many bytes I could receive, but rather I have to make sure that I prepare a buffer which is large enough. Then I create a datagram packet to receive within this buffer. I set the timeout to be 60 seconds in which I should receive the data. Otherwise, I will throw what was already, I will just do nothing if I will not be able to receive with my datagram socket. Then I ask the socket to receive within this packet. And now, when I receive the data, because I can get it from everywhere. There is no connection to a remote partner which is sending me the data through this channel. I need to specify what was the endpoint from which I took the data. This is important because with a talk application, this would have to go to a list of available connections. But because the protocol is connectionless, I only have the remote endpoint, the remote socket, internet socket address. So the way I handle this, and in general also the way I handle the session with a connectionless channel, is the following. I created a message class. Imagine that with TCP it's very easy to determine when a session is started and when it closes. This is because I have to accept the session will be maintained, and in the end it will be closed by the client. With UDP there is no connection, so there is no session with a remote partner. Therefore, I don't know when to add my remote endpoint to a list of available endpoints and when to remove it from there. So I created a message just to specify those three types of messages. So my message class will have a type, and I have here defined some constants for the type. It will be serialized, therefore it has to be serializable, and it will contain a payload which is going to be the text that we send. Now, when receiving this message, I will know for sure from which endpoint I got it. Therefore, this should be fetched, should be set on my message object. But I will not serialize this value, so it has to be volatile. Now, I also have some utility methods to create a subscribe, an unsubscribe, and a talk message based on the code of the message, the type, and the payload. And there is some setters, and there is a setter and a getter for the internet socket address. Now, when I receive an object, if the object is of type message, I know for sure I have a field to set the internet socket address field. So what I do when I receive a message, I will have the information in my datagram packet, which is the address and the port, and I then create an internet socket address with this data and set it to the message. Later on, the message will be used to just add this endpoint to a list of available endpoints, and when a connection will send me some data, I will be able to go back and broadcast this to the available list of client endpoints. And in the end, I just return what I received. So this is how I handle the transport layer with TCP. Now, in order to start the server and configure it, I have an utility settings class, which is reading those values. The name of the host, in my case, it's an IP address, and it's the loopback address and the port. So I have a class which is reading those keys by just opening a resource bundle on top of that property file, and then taking the name of the host and parsing parsing the port for the connection. Now, how do I implement a server? I do it in the same way. I have a console application which is starting the server. The server should be auto-closable, and I call the start method to listen on the given port, and then I say to the client, you know what, I'm just accepting commands from you, and if you type exit, I will stop it. So I create a scanner to read from the starter input, and then I just read the next line, and if the next line is null, that means that the console has been closed, or it is equal to exit, then I just break from this infinite loop, and that will be all. In the end, I call the server to stop, but I even don't have to do that because it is auto-closable, so eventually the stop method will be closed because it will be actually an alias for the close method. Now, I have an identical server here, which is supposed to run an UDP talk server. Now, let me just move on. How do I implement a concurrent TCP server? And this is the implementation. First of all, I made it auto-closable, so I will be able to use it in a try with resource statement. I need to have a list of client connections, and for me, a client connection is just the socket I use to communicate with the client. Now, this list will be accessed by several threads on the same time, and therefore should be synchronized. So I just create an array list and I synchronize the collection. Now, the server will have to have a dedicated socket server socket to listen for incoming connections. Now, in order for the server to be concurrent, it would have to execute a thread on each accepted connection just to receive data and process the data from the clients. But because this could lead to a denial of service in the end, I decided to use a thread pool. So instead of creating another thread when accepting a new connection, I will just dispatch a task to a predefined and pre-configured thread pool. What I do when I start the server, eventually, let's see what I do when I stop it. I have a close method and an alias for that, which is stop. And when I stop the server, if it was started before, I shut down the execution services, which is the thread pool, and then I close the server socket. Now, let's see the magic, how I actually set up and start the server. We create a server socket which is going to listen to any IP address, and this will bind and start listening on this port. Now I just create the executor service as being a new fixed thread pool, and usually it depends on how many available cores you have. So I will just take the number of available processors, which are the number of cores, and then multiply it by a number between 20 and 60. So this is a normal load for an x64 processor architecture. Then I submit a task to my executor service, and the task should listen for incoming connections. So while the socket server is not closed, I then try to accept a connection. This will actually perform a handshake with the request from the client, and eventually will produce a socket which will be used to communicate with the client. Now, for my server to be concurrent, I have to actually run some code against each connection that I accepted. So I submit another task for each connection, and this time what I'm trying to do is add the socket in the list of available clients, and in the end I should make sure that I remove it from the list. Then, as long as the socket is not closed with the client, I try to deserialize a message, which will be a string, and dispatch this message to all the available connections, like doing a for each on the list of client connections. And for each socket connection, I then serialize this message on the socket. So this is basically how a concurrent TCP server works. Just accepting connections and starting a thread to dispatch, to read data and process data from each connection. Now let's move on and see actually how we implement a concurrent UDP server. Now if we go in here and see how the server looks like, it is also auto-closable, and it has an alias for the close method, which is stop. which is the pair for start method. And what I do, I have a datagram socket to listen for incoming packages, and if this is null and is not closed, I will then close it. So what I do when I start the server, first I stop it because it could be a restart, and because I have no connection with the client, but rather I know what are the endpoints from which I receive data from the clients, I have a list of available internet socket addresses. And this should be a hash, and I just create this. Now, I start listening on a socket with a datagram socket, on a port, sorry, and this will receive data from anywhere. I set what is the maximum size of the buffer, like 10 megabytes, and I submit a thread which is supposed to listen this socket. While the socket is not closed, I try to receive something from the socket, and then for sure I will have to have exclusive access to the list of endpoints. And what I'm doing here, it depends on the type of the message. If the message is of type subscribe, then I will have to take the address from which I received the data and add it to the list of available endpoints. If it is an unsubscribed message, I will remove this address from the list. And if it's a talk, I then iterate through the available endpoints and send the message with using my socket to that endpoint. So basically, this is how I proceed with UDP. And this time you see that because I'm receiving data without a connection, I don't know when the connection starts, whereas with a TCP connection, I know for sure when I accept a new connection, then the connection will start. So when I'm accepting a connection, I add it to the list. When the socket will be closed, I remove the connection from the list. But with UDP, there is no start and end. So I have to somehow specify from the client that this should be a subscribe request, this one is an unsubscribe, and this is a talk. So by the type of the message, I know if I have to add the remote endpoint of the client sending me the message, if I have to add this to the list of available endpoints or remove it, or even broadcast the message. So this is another feature I would have to implement with UDP because there is no session with the channel. Now, the client application is straightforward. First of all, I would have to implement like a proxy. This proxy is supposed to connect to the remote server and then listen for incoming messages from the server. So in case of TCP, I will connect to a host and port, and I also define a callback interface with only one method, just to notify someone, to notify the user interface about the received message. Now, I create a socket, and this is gonna connect to the endpoint, and I submit a background task. I create a background task and start it, which will eventually listen for incoming requests. So it's trying to receive with the transport layer from the connection, from the socket, and then broadcast to the callback the message that was received. Now I also have an utility method to send a message, which is going to serialize on the connection my data. And this is also auto-closable, so I have a method to close it. Now, moving on. How I do this with UDP. It's a bit different, but not quite. So I also connect to a host and port, but this time I'm not actually opening a socket to connect to that, but rather I create a datagram socket. I set the maximum buffer size of the socket. I create an endpoint to send it to send data to that, and I use the transport layer to send a subscribe request using my data socket connection to this endpoint. So you see there is a difference between the server, the way I open the data socket on the server and on the client. If we look back on the server with UDP, we open the data socket with a port. That means that the client, that my application would listen for incoming packages. But in the case of the client, I open the data socket with no port. So this is going to be used to connect and send data to a remote endpoint. Once I send data to that, the endpoint will be registered, and eventually when some other client will send a message, my endpoint will be addressed with a request to receive this message. So I create a background task and listen on my data socket and try to receive something from it. I will not receive anything unless the server will eventually send something to the client. And then I notify the callback to just process the incoming message. Now, how the UI looks like, this is a simple standard widget application shell, and I can even open this with the window builder editor. Now, I have a sorry for closing it, let's reopen this again. I have a very small application, which if I go to the design tab, you'll see it is upside down. But basically, let me fire up the designer. This is actually the title of the window. I have a list and I have a text to enter some messages. Now, I open, this is the way a shell is opened by SWT Graphical Manager. So I take the default display, create a shell, which is going to be my window, open it, do a layout on the controls, and then while it is not disposed, try to read and dispatch messages, and also do a sleep on the display in the meantime. Now, what I do when I create my shell, I attach a listener, so when it's going to be closed, I also close the client connection. It is doing a layout. I set a grid layout with only one column, and the size of the components inside it should not be the same. I create a list. I layout the list to fill vertically and horizontally, and then I create a text and other text listener, a key listener. So when I release a key, if I enter something and release the enter key, and if I enter something in the text box, eventually it will take what I filled there and send it to the client, send it with the client to the server. Now, after creating the UI, I will connect to the server, and I have here a callback. So when I receive something from the server, I will add this as an item in my list. And because I'm not allowed to do that with a background thread on the main thread of the UI, I will have to invoke it on the same thread with the UI. So I do an async exec with the display just to perform this call on the user interface thread. Now, this is for creating a contents, doing a resize of the window, and setting the focus on the main control of the form. The same approach I do with an UDP client, having this already described. The UI, which is consuming the UDP client, it's identical. There is no difference whatsoever. So the client implementation is the one which differs, but the rest, the way I consume the client, is the same. So let me just start first the TCP demo. I will just open the program and run it. So you see it was started, and I will just run two connections to the server. So I'll just I will just run this as a Java application, and that's gonna connect to my server, and this is the UI. And I'll just start another one just to make sure that they talk together. So this is the second UI I'm using. So this one, it says, can you read me via TCP? And the answer, who knows? Yep, I can. Okay, so this is simply a SPI, easy as SPI, doing nothing, but just showing you what are the differences between TCP and UDP with respect to a talk application. Let's just close this by typing exit command, and it was terminated. Now let's start the UDP server. That's a Java application. I'm starting here, and it was started. And let's just start one client application. The application has been started here, and let me just start another one just to see that they are working, and they can send messages to from one to the other. So this is the same UI, and this time it says, can you read me via UDP? Okay, more or less. Yeah, and the answer is the same. Yes, I can. Okay, so yeah, you see that they can talk to each other, and eventually I will close the UI clients and then close the server as well. So let me just enter the command. Yeah, so that was all. Thanks for watching.